we start with a little bit of recap and then we go into our topic. Recap will always be, because we have not done any numerical so far, recaps are always formulas. The first formula came from voltage is said to be work done by upon charge. Then number 2, we said current is equal to Q upon T. Then the third formula we have now derived is V by I is equal to R, which is Ohm's law. So all voltage, current and resistance has been introduced to us by now. Okay. Also, if you in this section, we can also say potential difference delta V is always final potential minus, rather than writing this as VA VB, I would write this as final potential minus initial potential, which is work done by an external agency in moving a charge from initial to final position divided by Q. So this also we should know. Now, before proceeding further with resistance, let's now talk about the symbols. So, okay. So the circuit symbol for a resistor, this is not for resistance actually, this is the symbol of a resistor. All this we will study today. Resistor. A resistor shows resistance. Honest guy shows honesty. Idiot shows idiotism. So many books will write that the symbol of idiotism is this. No, this is the symbol of idiot. Got it? Resistor. It's a device. So this resistor is a fixed resistor. Fixed means fixed value resistor. Then we also have something which we call as variable resistor. Variable resistor. A variable resistor in a circuit diagram will usually be represented by an arrow like this. If you see any old days radios or twin ones or music systems, then the volume button is actually a variable resistor. Volume button is known as a variable resistor. Okay. In labs, we will see another type of variable resistor. This you see only in labs. This is called a rheostat, and the rheostat is represented in this manner. Now we will understand what it means. Okay, this is the rheostat. So in a rheostat, there will be three points to connect. Okay, understand this. There will be 3 points to connect. Imagine if you have connected one wire. Say suppose if you have connected your circuit wire on this, and if you have connected your circuit wire on this, then your current encounters the full value of the rheostat. Rheostats have a range. Let's say this rheostat is 0 to 500 ohms. This has a range, variable. If I connect here from here to here, means I am utilizing the entire coil. It will be coiled. You are using the entire coil. So if you connect here, how much of resistance are you using? Entire 500. Have you understood? Right, fine. Rheostat is a variable resistor which we see in labs. This resistor will be something like, there will be 2 clamps. Okay, it's a very interesting device. There will be 2 legs like this. There will be 2 legs out here, and there will be a button out. This is one of the terminal. This is another terminal, and a lot of wires will be wound around it, just like a tennis ball. What do you call it? The container of the tennis ball. So like it will be like this, and on top of it, it's very dangerous device actually. On top of it, there will be a slider sort of a bangle, and this bangle actually keeps on sliding. That is this, which we call as a jockey. We call this as a jockey, right? And this will be on one frame. It will be on a frame. So the third point will be this. This point is actually this point. This point is, say, this point, and this point is this point. This is a rheostat, right? Okay, I'll tell you some interesting stories here also. So in a rheostat, if I connect between these two, then I'm using entire 500 ohms. Okay? If I connect my wire here, then I have a choice to vary the resistance. Say I'm using only 75 ohms up till here. I pull it more. I'm using how much? say 90, 100 ohms. Full, if I pull it completely, it will be this side, it will be 0, this side it will be 500, means you're using the entire 500. Have you understood? And if I say that don't use the resistance at all, then I'll connect between here and here and I'll slide it so that the jockey comes here. Now no resistance is being used, it's just like a wire. You understood? Okay. So these are available in colleges, these are available in schools, and in engineering colleges, these are available in all experiments we do this. So theaters and all happen, right? You know, theater is something which is live. There's no retake. So there will be a stage, there will be the audience, and between audience and stage, there is a control panel section where a lot of people will be sitting absolutely head down, and the entire plot of the theater will be given to them, because many scenes you have to change lights, right? Are you understanding what I'm saying? Lights have to be changed, then shadow has to be brought, this, that. So these practices go on, and there are some set boys in this college who will do all these things, because this is passion and interest. So the entire plot will be given, and you have to read, okay, this is when the father comes and he starts weeping. At that time, stage light has to dim down. In our days, we didn't have so much of Arduinos and microcontrollers, so we used to use only rheostat. Now these are working at 230 volts, and there is no light in the stage. All you have to see is the script. हाँ बाप आ गया है, and बात नहीं कर सकते हो ना, because you can't talk. So you have to just reduce. If you get a chance to see a theater, always go and see theaters. Theaters have got no retake. It's absolute craftsmanship, and you have to reduce. Sometimes if your hand goes and touches this coil, what happens to you? You get you get a shock. So you have to be very careful. Okay, this light has to be reduced. This, so rheostats are used for that. This is clear. So let's see now. Let's see a typical setup of a Ohm's law experiment, okay, which we used to do in grade 10. You may do, you may not do, but you may get a question based on Ohm's law verification. Tell me. Yeah. Ohm's law verification, okay. So what does Ohm's law say? Ohm's law says V upon I is equal to R, and we will pick up a conductor. We'll pick up any sort of a conductor, means you will take a sample of it, which is a wire, and you will see for this wire that whether it obeys either a yes or a no. Okay. If this wire obeys this, then I call this wire as a ohmic conductor. Not everyone will obey. If it doesn't obey, I call it non-ohmic conductor. Is this much understood or not? All conductors have inbuilt resistance in them. Conductors which obey Ohm's law. What is Ohm's law? It means there has to be a linear relationship between the voltage and current. If the relationship is linear, then that conductor will be called as a ohmic conductor. Means in that conductor, the resistance should come constant for different values of voltage and current. And if you find that, sir, no, it is not constant, then we will say that it is a non-ohmic conductor. Now, how do you set up this experiment? These are things, if you understand, it will become easy. So let's say this is my unknown wire. This is the wire whose resistance is not known, right? Resistance is not known. And what I have done, I have connected one emitter with it, and I have also connected in parallel one voltmeter with it. What will these two devices do? The voltmeter will tell me what is the voltage across the conductor. The emitter will tell me how much current is going through the conductor. And what is Ohm's law? Ohm's law tells me that the current flowing through a conductor is directly proportional to the voltage. Means if I increase the voltage, if V value goes up, Bakul, close it properly. If V goes up, A should go up. And this go up should be in a linear manner. So means I have to change different values. So what I do, I then bring one cell in the circuit, but this will give you a fixed voltage. So I also introduce one rheostat in the circuit. Got it? And I complete this circuit. Clear? So what this rheostat do? This rheostat will control how much current is going through this resistor. Okay? Fine. So this is how my current is going and this voltage. And I start making some observations. My observations are like this. These are my serial numbers. This is what is the voltmeter reading. This is what is the current reading. Voltmeter means this is the reading of the voltmeter. This is current. Here I will calculate the V by I ratio. Basically, I am calculating resistance. This wire's resistance is constant, right? And here I write what is my average V by I, which is equal to R. Clear? Very simple experiment. So my first reading, I keep this in some position, and I see what is the reading out here. I say that my reading is V1. At that time, emitter is reading A1, or say I1. I get a ratio of V1 upon I1. Clear? Then I slowly change this rheostat. If you change the rheostat, you are varying the current. Just like that theater. You're dimming the light or you're decreasing. Have you seen dimmers in many people's houses? Light dimmers. The voltage regulator is called a stepper. Cut. It's a stepper. That's also a variable resistance. But there is one more device available in many people's house. It will be they don't have their fan regulators as cut. They have it just like slide. Not slide, just roll and clockwise, anti-clockwise. That's called a dimmer. That is called a dimmer. Okay. So my second reading, I get a V2, I get a I2. So another again, I get a V2 by I2 and blah, blah, blah. I take say 5 readings, V5, I get a I5 and I'm plotting what is V5 by I5. Before that, what I do is that, children, no conductor in this world will be a pure ohmic conductor. Please understand that. Nobody will be a pure ohmic conductor. So voltage is always on the y-axis, I. And these are my coordinates, V1, I1, V2, I2, V3, I3. So I start plotting them. When I plot them, you will generally see that if it is an ohmic conductor, they will come in this manner. समझ में आ रहा है? Say the plot will come something like this, like this. And if your experiment is, you have done it truly and you have not bluffed, then it should not be on a straight line. If it is on a straight line, if I am your external, I'll straight away cancel this. It cannot be straight line. Straight line means you have bluffed. Experiments cannot be that correct. So what we do here, we will fit what in statistics we call is the line of best fit. What do we fit? We call as line of best fit, the best possible line. While fitting this best possible line, one point may not lie. And this is exact experiment. We call this as an outlier, possible. So overall we say this is an ohmic conductor. And when you do these values will be coming in the range of, let's say the resistance is 2 ohm, you'll get 2.1, 2.01, 1.99, 2.02. So, and then you do an average, add up all. So all these, and then you find out what is the resistance of it. This is the experimental setup of Ohm's law. Did you understand? If there is anyone who has not understood what is the experimental setup of Ohm's law, then you can do it at lab. Any question, don't hesitate. Okay? So if it is an ohmic conductor, first of all, we don't do this. We just get these and we plot it. If you are getting a straight line. If it was a non-ohmic conductor, then my plot will actually come out something like this. It will not come as a straight line. We call that as a non-ohmic conductor. Here the resistance is not constant. Look at, if it is a straight line, then the slope is constant. This is slope, right? Y by x is slope. Slope is constant. Make a child sit here. Here the slope is not constant. So wherever the slope is, the plot between V and I, the slope tells me about resistance. And if the resistance is constant, that means the conductor is a ohmic conductor.
It's between variable resistor and rheostat.
Same thing, variable resistor. Rheostat is a lab device. It is a lab device. What is the difference between a near-left frying pan and that catering person's chicken that is used in, both are frying pans, that is used for a large scale. This is an industrial device.
But same purpose.
Same purpose. Even if you go to somebody's house where they are adjusting fans with buttons, as I told you, that is also a variable resistance. But we call that as a dimmer. You can't use that for making experiments. So in my childhood, I used to do, like if there is no fan, the regulator, I used to connect the bulb. So like ghost scene shooting, tuck. So the bulb, what happens? The current through the bulb is reducing. So the bulb will glow dimmer and dimmer and dimmer and dimmer. Now I do the same thing over app, digitally controlled, and you say brightness 33%. All right, Jaideep, now brightness 33%, and it will do 33%. Okay, chale aage. In fact, fans which you buy, the table fan or the pedestrian fan, I have this video on my YouTube channel. You can see these fans come with speeds like 1, 2, 3, 4. Now, once the rain comes in, the temperature will come down. You will find that 2 is actually much more speed and 1 is much less speed. You're not happy either at 1, neither you are happy at 2. Now you want digital control. Now that device, after learning, I have made. That you can make. And that device you can make over app. Then you put a IoT on it. Mother has put the child to sleep and she is in Ratnadeep. Suddenly it is raining. Mother feels that the child will feel cold. So mother can give a Google instruction from there and the fan will automatically reduce at home. So basic funda is here. Chale, aage. Okay. Right. Now we see this topic is very, very important. Resistance. Children make a lot of mistake on this. Resistivity. You don't know what is resistivity, so don't worry. You don't know what is a. So I'm putting this as a heading. Okay, resistance, resistivity, resistor. People confuse among all these three things, right? The other day I was explaining grade 12 also, same thing. You can also go and see the same video. It's there on the YouTube channel. Resistance, resistivity, and resistor. Right. Experimentally, it has been found out that the resistance is directly proportional to the length of a conductor. You at your level will not understand what I mean by this. Resistance is directly proportional to the length of a conductor. Okay, that means longer the wires you use, more will be the resistance. That means a question comes here, sir, why are headphone wires up to a standard length only? Why didn't they give me big wires so that I will sit in my bedroom and I will be able to hear from my living room? That's because over a distance, the signal will drop. The signal will drop. Even if you are illuminating a bulb right now, you're illuminating your table lamp just next to the plug point. So let's put a wire here and let's extend the wire up till say another 60-70 kilometers from here. And if you switch it on, you will find that the bulb is now glowing at the dimmer glow. That means there is a resistance which has been picked up by the wire. Okay, more is the resistance, less resistance is like a obstruction. So the resistance is directly proportional to the length of a conductor, means ohmic conductors. Extension cords, that length is not that much, but if you actually microscopically see anything where you increase wire length, it will fall down. The quality of the signal will fall down. Now, henceforth, whatever we are studying, whether we are in grade 10 or grade 12, we are only studying ohmic conductors. Means whatever we are going to study, their Ohm's law is valid. Means V by I equal to R can be used. Understood? So resistance is directly proportional to length. So I say R is directly proportional to the length of the conductor. Okay. Now there is another concept which is called the cross-sectional area. Cross-sectional area. Let's understand what is a cross-sectional area. So if you buy a vanilla ice cream cuboid, what you call as a brick, and you cut that ice cream brick in middle, the cross-sectional area is a rectangle that you see. Got it? Have you understood? So if you take, say something like that water bottle, if you cut it on the horizontal axis, the cross-sectional area is a circle. Clear? So cross-sectional area is what we are interested. When we define current also, we said that how much of electrons are passing through the cross-sectional area. So we find resistance is inversely proportional to the cross-sectional area. Now this I can explain you at your level also, you'll be able to understand. Let's say I had a conductor whose cross-sectional area was A. Now A is a portion of the conductor. Do you agree? A contains free electrons. A is also a metallic part, na? It's just you have chopped off my hand and you are looking at my cross-section. So A contains free electrons. What you have done is that you have suddenly reduced the cross-sectional area to half. A by 2. Don't you think the number of free electrons and the area through which they are playing has got reduced? If the free electrons have reduced, the current will reduce. In a manner, you are promoting resistance. In a manner, you are promoting resistance. Yes or no? Earlier, we were going through this much conduit. Now the conduit has been made half of this. Everyone cannot go. So if you reduce the area, the conductivity goes down. And what goes up is known as the resistivity. Is this understood? Resistance. Resistance goes up. Clear on these two? If I combine these two statements, we say resistance is directly proportional to L upon A. Now in grade 8, you have learned whenever there is proportional, you have to, and you want to equate it, you have to bring a constant of proportionality. So we bring one constant of proportionality. We say this is L upon A, and that constant of proportionality is the Greek letter rho. Likhna सीखिए इसको. This is called rho, RHO. We used to use it in density also. How do you write it? Look at my pen like this. P. How many I have made? Now you can make. You should be able to make it. Now, rho L upon A. Got it? This fellow, and get it very clear today, this fellow is known as resistivity. Resistivity. This is known as resistivity. Okay? Now our discussion starts. I'll change this slide and I'll go back to one different slide. Okay. Let's say you have a piece of wire. This is a piece of wire, and this wire is made up of copper. This is a piece of wire which is made up of copper. There is some property, and we are talking all in terms of current, voltage, and resistance. Okay, there is some property which we say is fundamental property. What do you mean by fundamental property? It means that this does not change with change in geometry. This does not change with change in geometry. This wire is there. You turn it, curl it, twist it. There is something property which does not change with its geometry. Have you understood? That property, no, not Ohm's law. That property is known as resistivity, which is rho. So based on this, what I'm trying to say is that I used copper. Now, whether this was a 1 meter wire of copper with A cross-sectional area, half meter copper wire with B cross-sectional area, or a big drum of copper, or a big, you know what the word billet? Billet is something like slabs, like staircase slabs, cuboidal slabs. We use it in metallurgy, or a billet of copper. This value will never change, will not change. So can I say that this is material specific? It will change only if you swap copper with aluminium. Pay utmost attention on this topic, okay? It will change only if you swap aluminium with copper with aluminium. Otherwise, it will not change. Resistivity does not change. So what did we understand? Resistivity is a material specific thing. And so I am saying that this particular wire has a resistivity called rho Cu. Rho Cu stands for the resistivity of copper, right? Have you understood? Okay. Now what we do, I take this wire and I change its geometry. Okay. Go back to Ohm's law. I had written two conditions: temperature remaining constant and other physical parameters remaining the same. Why we use that word, you'll get to know now. Now, what are you doing? You're changing the geometry. So in layman's language, if I'm changing the geometry, I can assume that I am changing length, I am changing length, and I am changing the cross-sectional area. Try and understand. I gave a piece of wire, similar wire, means same cross-sectional area and length, I gave to these three boys. One fellow turned it, one fellow curled it, one fellow twisted it. With their 3 acts, they could not change something which is called resistivity. Now what they have done, they have tried to play with geometry. He has made the length as L dash and the area is A dash by melting it, and he has pulled it further. He has made the length as L double dash. He has made it as L triple dash, means they have changed it. In this case, they have given birth to a variable property. Obviously, they have given birth to a variable property. A property which is now varying based on the type of the length they took and based on the type of the area that each individual boy took. This property is known as resistance. Okay? Denoted by R. R. So if Aryash created a resistance R1 because he used copper's resistivity, but he chose L1 length and A1 cross sectional area. So Aryash's resistance is different. Means the wire or the shape that he created is giving a different resistance. Our friend Vakul now has a resistance of rho copper multiplied by L2 by A2, and our friend Neil has R3, which is rho copper into L3 by A3. In all these 3 cases, they have a variable property, and they changed its property, and by changing its property, finally they created article A dash, A double dash, A triple dash. You understand? A dash is one article whose length is L1 and this 2. These articles are known as resistors. So if you are an electronics enthusiast, a hobby electronics enthusiast, you have a habit of going to the market and saying, Bhaiya, 100 ohms ka resistance dijiye. Wrong. 100 ohms ka resistor dijiye. This resistor will display a resistance of 100 ohms. Made up of some material, maybe nichrome, constantan or whatever, having a specific resistivity. Sometimes we say, Jaydeep sir, your house is so messed up. Why don't you hire some laborers and get your house sorted? Your English is wrong. Hire some laborers who in exchange of money will give labor. Got it? Is this explanation clear about resistivity? So resistivity does not change as long as you don't change material. Resistance can keep on changing based on what shape you picked out of that material. Now we will give you some more interesting examples before proceeding ahead. Is this pakka clear, understood? Okay, let's try one more thing. Okay, I have a small slab of copper, right? Or say not copper. I have a slab of say silver. I have a slab of copper, and I have a slab of aluminum. Slabs. What shape and size, I don't know. They're just slabs. And I've been given I'm a designer. I'm an electrical engineer, design engineer. And they say, the most rich person says, can you design a headphone for my daughter? Okay. And it should have the best specs. So headphone means the sound quality should be very good. I should pick up a material for the wire which is the best conductor. Which one should I pick up? Silver. Why are you picking up silver? Because silver's resistivity is the least as compared to copper, as compared to the resistivity of aluminum. Now do you understand? You're trying to make rasmalai, so you have initially picked up full cream milk so that your rasmalai comes very beautiful. It's just like that. Rasmalai later on shape will be different. But one thing specific is I picked up full cream milk so that I selected something which is this. Right? But the market, we will have many people who will buy headphones. We will have chapris also who will buy headphones. Chapris will not be ready to shell out that much money. So when we go into business, we design something which we say is always techno-commercially feasible. Techno-commercially feasible. Yes or no? So if I produce only iPhone quality headphones or Sony quality headphones, will they work? They will not work. I need some headphones quality which will be sold right outside Secunderabad railway station. 80 rupees. Somebody has to pick up. So I have to now compromise on what? I have to compromise on the material. But still that person says, sound acha nahi aa raha hai. So you, instead of taking full cream milk, you have taken ordinary milk. Now you have to pay more attention to make the perfect rasmalai balls so that the taste comes good. So what are you going to play now? Since you have already picked up a material whose resistivity is not that good, the only way you can now reduce the resistance is by going for the best combination of L and A. By tweaking this also, overall, ultimately you are going to make a headphone wire. The resistance of this wire should be less. Material was not in your hands. What is in your hands is to tweak L and A. Have you understood? One more interesting example. So there is a boy. I tell him, go to Ratnadeep and get this stuff for me. Oh, I'll not go now. Don't watch TV. Oh, I'll watch TV. Very stubborn. Very stubborn. But there can be some other boys also. Go to Ratnadeep. Okay, I'll go to Ratnadeep and get it right now. Switch off the TV. Yes, I'll switch off the TV. They are, somebody is obedient, somebody is disobedient, like that. Nature differs from people to people. Do you agree or not? So biologically, let us go, means travel back in time and see this boy at the zygote stage. Right? And on this day, the DNA of this boy was sealed forever. In this DNA, there was a component called stubbornness also, which was codified. Agreed or not? We can't change it. We can't change it. That's why sometimes we say that when you try to plant crops and all, why do you take the best seed? Does the best seed means that you'll get the best crop? No, at least I have taken full cream milk. Chances are better, yes. But with a normal quality seed also, if you give good fertilizers, means if you tweak on LNA, you can still manage. So this boy's DNA level stubbornness is codified. This is analogous to resistivity. And suppose this boy has grown up to be a big fat couch potato. Inertia is directly proportional to mass. Do you expect him to be a super stubborn? Yes. Yes. We can. But in movies, they sometimes show story that a dying robber gave his son to the police officer. Isko aap acha banayega. And that boy becomes police officer also later. Why? Because you didn't get the good codified DNA, but you can at least change it. I hope I have given enough examples to make you understand what is resistivity, what is resistance, and the boy who will grow up will be called as the resistor. Is this understood? Okay. So we go back to this particular sheet. Now, is it clear what is resistance, resistivity? So chance now is to define what is resistivity. So we say, let the conductor. Achha, why I am saying conductor? Conductors only will show resistance. No one is a good conductor. There is no perfect good boy, no perfect good girl. Let the conductor be of length equal to 1 meter and cross-sectional area be 1 meter square. तो इसको देखते हैं कैसा होता है. R is equal to rho 1 meter by 1 meter square. Meter takes away 2. So I get R is equal to rho, and I have, if you go by units, I have ohm on this side and I have got a by meter on this side. Understood? 1 meter remains. Rather than writing first, understand. So it becomes, if I change it, it becomes rho divided by a meter is equal to R with ohm. And I further say rho is equal to R ohm meter. But not always. This is the mother's equation. This was when you created a special boy. Length 1 meter, cross-sectional area 1 meter square. You could have kept it as 10 meter, 10 meter square. Now it's our time to define resistivity. When you go for a combination like this, resistivity equals the resistance. So how do I define it? Likho mat, pehle samjho. Resistivity is the resistance of a conductor of unit length and unit cross-sectional area. Take unit length and unit cross-sectional area. Take a conductor of copper, but there is a condition. Choose its length as 1 meter and the cross-sectional area as 1 meter square. It will have some resistance. That resistance is the resistivity of copper. What is the DNA level stubbornness of the child? Not the stubbornness of the child. Stubbornness coded in one cell of that particular boy. Resistivity is the resistance of a conductor of unit length and unit cross-sectional area. If I would have manufactured a piece of copper such that its length is equal to 1 meter and its cross-sectional area A is equal to 1 meter square, have I not given one geometry? Yes. This geometry will have some resistance. This resistance is equal to the resistivity of copper. And the unit of resistivity is always ohm meters. What is the unit? Ohm meters. समझ में आया? Resistivity is the resistance of a conductor of unit length and unit cross-sectional area. If you change this dimension, you will get resistances, but they will not represent resistivity.
Rho by L by A, the resistor itself.
Which one? Resistor, any resistor is R equal to rho L upon A. Rho depends upon the material that you have chosen, full cream milk, and L and A are the shapes you are giving to those rasmalai balls or whatever you are making. This is resistance. Resistance is always, rho is what is coded in you. By birth, some bit of stubbornness is there in you. That is rho. That does not change whether you are a child or you have become elder. Days pass, L and A changes. So you have a different resistance at every age. But your resistivity is what was codified right at your birth. Got it? So resistivity's unit is ohm meter. Ohm meters. So just for your knowledge purpose, if you try to look at, say for example, if you try to look at resistivity of conductors, resistivity of conductors are in the range of 10 to the power minus 10 to 10 to the power minus 8 ohm meters. Conductors don't have that good resistivity. That's why they are conductors. But if you see the resistivity of insulators, they are around 10 to the power 18 ohm meter. बहुत high है. 10 to the power 18 around. So here what do we have? We have something like glass. That's why the screwdriver's back end is made up of glass, rubber, ceramic, silicon, all these things will be. And if you see somebody who is in between, that is semiconductors. Semiconductors. So if you see, the resistivity of semiconductors is always in between that of insulators and silicon. Silicon is not an insulator. Silicon is a semiconductor. Germanium, those are called semiconductors.
What are semiconductors used?
The entire world is, your phone is a semiconductors, electronics. Electronics. All are sand. Your cell phone is also sand, end of the day. Acha. Stubbornness. We are talking about disobedience. So let's give some mathematical values. How do you relate disobedience and obedience mathematically? How will you say? Rough gauge. How will you correlate disobedience and obedience? Obedience is 1 by disobedience. I देखो ना, अरे मजा लो ना. Obedience should be 1 by disobedience. Arey, what is modeling engineers you will become? If the disobedience factor is high, then the obedience falls down. Inversely proportional. And it, अच्छा वो बोला था क्या? Sorry, फिर सुना नहीं. And if the disobedience is low, then the obedience should be very high. So similarly, in electronics, so far you have studied only about something called resistivity. Resistivity is something like, for a conductor, it is a disobedience factor. It does not allow current to go. So we need to bring something which is known as an obedience factor. The obedience factor is represented by, this is small sigma. It is known as conductivity. Now there is a very interesting thing. When we talk about metals and conductors, we do not study conductivity. We study resistivity. However, if you are studying electrolytes, and when you will be studying electrochemistry, that's why I said electric current has got three effects: heating effect, magnetic effect, chemical effect. The chemical effect is studied in chemistry. In electrochemistry, we don't study resistivity. So when you go to grade 11, you'll have a chapter on electrochemistry. There you will be only studying conductivity, 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 conductivity. वहाँ resistivity नहीं पढ़ते हैं. Like if you see in the if you go to old Hindu mythology stories, then all the sadhus will only talk in terms of punya karo, and the daityas will only talk about pap karo. So in their world you study pap, in their world you study punya. So conductivity. So resistivity is actually expressed in what? Ohm meter. Okay. Conductivity has got just the reverse unit called mho. Ohm ko ulta kar do, mho. MHO. But when you go to chemistry and all, this mho is now replaced, and now we use conductivity unit as Siemens. वो जो आप Motorola Siemens company, that has come from this conductivity. Based on this, that microcontroller company works. He smiled and he laughed. There, for what you are smiling, their eye is not there. That's a part of biology that you are studying. So he controlled his laugh. There's nothing great. You know, when we used to study biology, we used to have a ma'am, and anatomy used to be studied. The worst thing is that ma'am used to give us first 3 classes only to laugh. हंस लो जितना हंसना है. After 3 classes of laughing and all, then everything used to get normal. So I'm not angry at him. This is human behavior. Many children in classes, when I used to write about this company called Siemens, they used to saying this is Siemens. That is SEMEN. And this is SIEMENS. So now you can laugh out. And then once you're done, I'll progress to the next one. This is common. ठीक है ना? चले आगे भी? Yes. Otherwise, if you cannot appreciate the human body, how will you study medical? Anatomy is all about that only. ठीक है ना? चले. So this is done. This is done. Now next. Okay. Now let's talk about appliances. When we talk about appliances, every appliance has got a resistance. That's why many appliances in electrical engineering and these chapters will also be referred as load. Load means a sort of resistance. All appliances. Let's look at a electric bulb, the glass wala bulb that you have purchased from a shop. What will be written here? 230 volts. Correct? If I connect it at 230 volts, say if it is pulling a current of 1 ampere, I told you the other day, it pulls current. So it pulls a current of how much? 1 ampere. At that time, this bulb is analogous to a resistance R, whose value is 230 V by 1A, which is equal to 230 ohms. Understood? Clear? So many times you will find that a heater has been connected or whatever has been connected. End of the day, we show everything in terms of resistors. So a little bit of advanced knowledge. All appliances, any appliance that you see, from a washing machine to a mobile charger, in the world of electrical technology or electrical engineering, we group them in three subheadings. They are either resistors, they are either capacitors, or they are either inductors. Sir, what are the balance two? You will study in grade 12. Or the appliance can be a combination of all three. Like a fan has got a motor. Motors and other devices are usually classified as inductors. This in electricity is L, this is C, this is R. So finally, the entire house circuit is a RLC circuit. Sir, we don't have RLC, so we have got a Sony PlayStation, you know, the disc one. That is also some C or some R. And I've got a lovely hairdryer, that is also some L. A washing machine, all L type of devices are big current pullers. Washing machine, air conditioners, then that dishwasher, the first of all that batter making butterfly mixie, the red wala, idli dosa batter maker. Have you seen that butterfly, the big grinder? Those are all this. Okay? So in grade 12, we will be studying about these two. Chale aage. Okay. Our next topic comes as combinations of resistors. But before that, we will have to study now in detail series and parallel. Though we just had a grasp of it when we were studying voltmeters and ammeters. Chapter is slowly now picking up space. Series and parallel. A series is a combination where any device, suppose I have a device, now every device is a resistor as I told you, right? I will no more draw a bulb now. I will just draw a resistor. So this is a bulb B1 which has a resistance R1. He brought another bulb from his house that is having a resistance R2, right? Now there are many ways in which we can connect these two bulbs. One of the orientation is called series. In series, we will say, suppose this is the X end and this is the Y end, this is X end, Y end. We will connect X, this is Y, and again we will have X of the previous one, second one, and Y on this side. This is series. So as I told, series is like ringa ringa roses. Look at this child. Ringa ringa roses, pocket full. Understood? There's another pattern. So this pattern is known as series. There is another pattern which is known as the parallel pattern. There I will first keep this resistor. What is my resistor? R1. And there are some nice ways to draw it. So when you study circuit diagrams in electrical engineering, you should draw them in a nice manner. So the nice manner is make some. This is called a parallel combination. In parallel combination, X end, Y end, Y end. Clear? This is series, this is parallel. You should not forget. Acha. So let us pick up our series. Say this is your R1 and this is R2, right? And the current I is flowing in the circuit. So I will enter this fellow. Look. Current is always a stream of flow of electrons. Stream. Current एक बहता हुआ stream है. Consider it like water. So current is coming. Pluck, 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 pluck. Any other gateway found? No. Pluck, 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 pluck. So again, same current goes here. Pluck, 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 pluck. Same current goes out here. Have you understood? So in a series network, current remains constant. Constant means constant. Nobody is asking any question. अनुराग तुम तो एकदम चुप हो गए, मौन व्रत लिए हो क्या आजकल? Yeah, ये सब वो anyway, his school has taught him already, so he's good with this. Good. In a series network, current remains constant. Have you understood? But remember one thing, V upon I is equal to R. If I has remained constant, V will show something or the other. So this is series. Chunnu and Munnu. Chunnu and Munnu are connected to the same cell who has a voltage of V. He is supplying V. My mother making rotis. Will he eat everything? No. Will he eat everything? No. So if he eats X roti, he will eat V minus X roti. Agreed or not? So in a series, voltage always splits up. Wait, if these were two identical twins with equal amount of appetite, don't you think if my mother makes 6 rotis, they will eat 3 each? Right. But if chances are that they will always be unlike fellows. So, like say me and Vakul went together. Looking at my body, people will say, hey, he ate 6, this fellow ate 1. Actually, it's the reverse. He ate 6, I ate 1. Okay. So, we say in a series network, voltage gets distributed. Remember these two things throughout your life if you have study physics till 12 or if you aage study engineering. So the voltage V becomes equals to V1 plus V2, where V1 is the drop of this. So we call this, you know what we call this? We call this as potential drop. V current voltage was given. The drop across this resistor is how much? V1. And so how much should be V2? V minus V1. We did not give some rotis to some birds or cats on the road. Understood? So look at the interesting part. Now you will understand the beauty of voltmeters. If I put a voltmeter out here, this voltmeter will read V1. This voltmeter will read V2. अगर ये समझ गया ना, पूरा engineering electrical समझ गया. And if I connect an emitter out here, this fellow will always read I because it's the same current. But sir, current wanted to go here. Voltmeter has got high internal resistance. It will not allow. But, right? And if I connect a voltmeter out here, it will show me the entire circuit voltage of V. समझ में आया? That means here if I try to do how much current, if I try to do V2 by I get basically the value R2. If I try to do V1 by I get R1. Have you understood this thing or not? All right. In our next analogy, what we will do, we will say, hey, we can't make it so cumbersome. Don't bring two resistance. But sir, this circuit needs 2 resistances. I am interested that you bring only 1 resistance. You bring only 1 resistance. That means you are asking, नहीं, अभी कुछ मत बोलो. You are asking, don't put mathematics. You are asking equivalent of series combination of R1 and R2. My circuit board does not have place for putting 2 resistors. I can accommodate only 1 resistor. So I am actually looking for an equivalent of series combination. So I am looking for some R equivalent, which is same as putting these 2 in series. Our next job will be to mathematically find this value. And similarly, let's also study this circuit. So this we will be studying. Don't goof up, okay? Let's study this circuit. Okay, this is voltage V. Now look here. Now look what is happening. Current, children, I know the diagram is a little bit mutated, but I don't want to change the board now. The current I is flowing from here. It comes here, and then the current thinks, where do I go? भाई तू इधर चला जा, मैं इधर जाऊंगा. It splits into I1 and I2. I1 starts traveling. Pluck, 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 pluck. I1, pluck, pluck, I1. I2 has also come here, I2. Then you sometimes say, when your parents are eating in a restaurant and you are those brat children, hey, these two roads meet at the same place. You see some children, they'll be running around and they'll say, hey, ki jagah aa gaye? So I2 and I1 again combined and become I. So what did you get? You saw that I split up into I1 plus I2. Time for us to write that in a parallel combination, current gets distributed. Just the opposite. Just the opposite. Current gets distributed. In a series, voltage gets distributed. In a parallel, current gets distributed. Fine. We were having V voltage on this terminal. Look here, look here, look here. Likhna baad mein. We have V voltage on this terminal. कैसे समझेगा? अभी जब तक मैं हाथ उठा दूंगा तुम फिर बोलोगे सर नहीं समझा. समझो पहले, ये रिकॉर्डिंग हो रहा है इसका. We have V out here. The same V is sensed by R2. The same V is sensed by R1. V is not splitting up. So we say in a parallel combination, voltage remains constant. Have you understood? So let's make some diagrams out here. If I put a voltmeter out here, how much will it read? V. If I put a voltmeter out here, how much will it read? V. If I put a voltmeter out here, how much will it read? V. But if I put a ammeter out here, how much will it read? I. If I put a ammeter out here, how much will it read? I1. If I put a ammeter out here, how much will it read? I2. So the relation I will get is V by I1 will be R1 and V by I2 will be R2. Understood?
Yes, sir.
But my project guide is very, very insensitive to my hard work and he says, I can't give you place for two resistors. You do one thing, you put one resistor out here which can do the job of both. So in our next class, we also have to study that I need equivalent of parallel combination of R1 and R2. And this is very much required. Sometimes you may design a circuit where somebody will say, sir, I need 230 ohms. Market 230 ohms is not available. But we found 115 ohms, 115 ohms are available. Can they be used? We have to see. Or say the market is giving, I want 230 ohms, but the market, I have 230 ohms, I need 115 ohms, but the market has only 230 ohms. Only 230 ohms. And I need 115 ohms. Can I do that? That we will see in our next class. Means I have to change the way I connect resistors. Either I have to make some series combo, some parallel combo, end of the day I have to achieve it. So networks might have, then there can be a network which will have a parallel as well as a series. Just to make your life a little bit more miserable before you go. You are thinking life is always like this. No, life may be like this also. Life may be like this also. Okay? Life may be so miserable that this particular thing may actually be part of another this also. Okay? Some boy has designed a circuit like this and this is perfectly working, but we want small miniature component. I say I don't want all this. I just want one resistor. ये पूरा तामझाम खत्म करके एक में दिखाओ. This is the challenge of any electrical engineer. And for this, in engineering second year, we have a subject which is common to mechanical also. And the pass marks for this chapter is 35. People don't score majority. It is called ECA, Electrical Circuit Analysis. You will remember your grandfather in this chapter. And this is only one resistor. There you will get so many theorems. ECA is a They'll say, what happened? Did you get? I got a KT. I didn't pass. I flunked. What was the paper? ECA. Or else in computers, you will hear one paper called microprocessor. These are the papers in which people flunk. ECA. And the guy who is good in this, he's the bap of the engineer. Who's good in this? He can actually design circuits. And that is what is all about. Just like in computers, we say somebody writes a big code, somebody does the same job in a small code. So it's a good coder. So, okay, all this waits for you in your next class. So till then,